And here we are, part two of my lecture that focuses more on innovation itself and how to generate innovation. I hope you had some insights, watching the first part and doing some of the homework. I was asking you to come up with a technology in the healthcare domain that will be around in 10 years, 15 years, but is not around right now. And for the next for this session and for the next homeworks, I would ask you to come up with a technology that you may want to explore further with respect to innovation potential. So pick whatever you want, pick even something that exists around, that exists at the moment, and you don't need to have in-depth knowledge on this one. It would almost be that if you say, for example, you want to do a 3D print. I mean, that's one of the technologies that we do, so I can use that one. We want to use a 3D printed personalized patch for superficial application to treat skin melanomas. And basically this patch is printed with radiopharmaceuticals, radioactive materials. So you have this mole somewhere here and you put a patch on it, and this patch basically, this printed patch resembles the shape of the melanoma and then radiates deeply down. So this is one of the things that we do in our lab. Pick whatever you want. It's just more like an exercise of what you can do with that and what kind of methodologies you can follow, exploring technologies and actually getting down to innovation. So let me get my screen started. Here we go. So part two of two, I hope it's going to take about, another 45, a total 45 minutes to max an hour. What you have learned, or should have gotten out of the last lecture, listening to my 41-minute presentation, that exponential technologies, AI, blockchains, robotics, genetic and synthetic biology, genetic engineering, they will have a huge impact also on health. And what you can look, if you look at innovation potential, you look at opportunities where these technologies, where you can foresee the development of these technologies and how they actually, maybe you can intercept the development of technologies with the opportunities that healthcare will require. So, you remember also the later transition from a home care to a professional care stage, making things simpler, easier, cheaper. These technologies will continue to develop, and even if some of these technologies may not be able to do what you anticipate they should do, you can maybe foresee that they will do that in 3 or 4 or 5 years. So considering the development time takes about 2 to 3 years, this is what people do that foresee, they see what technology development will be able to do, and in 3 to 4 years, and already work on the algorithms that allow that then in the next years. So a lot of the AI technologies, this is a good example. AI itself, with the convolutional neural networks or other networks they use for supervised and unsupervised learning, they're around for 50 to 60 years. But they couldn't really be used up to now because the calculation speed of the processors were not fast enough. Now, even if you have now an algorithm or a process that works, but it takes an hour, you can anticipate that this process will probably speed up by a factor of 5, 10, 15 in the next 2 to 3 years. And then maybe it is feasible for use. So this is what I'm trying to convey to you, is technology will be improving in speed, in performance, in cost, in cost reduction. And even if it doesn't work right now, it may be so in the future. So major issue is, though, that a lot of us start and believe innovation process starts with a solution. So we have a cool idea, a cool solution, rather than with understanding a problem that it's supposed to solve. So what I'm trying to actually communicate to that the problem understanding and a proper problem understanding is significantly more important than having a solution. If you really understand a problem, it is much easier to find a solution that helps the stakeholders. Stakeholders is everybody who's involved in this process. So in a healthcare problem, it would be the patient, the doctor, the health insurance, the administrator, the radiographer maybe, or the nurse, the family. So there's all these stakeholders, and you need to understand the problem that they have with a certain issue. And only if you understand that properly, you can solve it by coming up with an appropriate solution to it. So I try to tell my students and my employees that they should invest a lot of time properly analyzing a problem statement, rather than to immediately jump to trying to find an AI solution or creating a device that solves a problem that really isn't a problem. You also have to be considering the fact that medical products need to go through a regulatory process. So they need to be approved. That can take several years, can cost you millions. I don't want you to really think too much about this, because it stops you from innovating. When you know that things are too complicated, then you may not want to do it anymore. But what you need to do for this regulatory process is that you include a risk analysis. What could theoretically happen? And this is a really good way of analyzing technologies and their potential by also looking at the risk they could have. So if you have an electric device and it's connected to the body, you could have you could have some electric current going through the body that has a very negative effect. Or you could have a connection to a ground, or you can have a connection to a higher voltage, or etc. It could be a failure in the software, and if you have a pacemaker, and the software or the program doesn't work anymore, gives the wrong information, you actually have a not a positive but a negative effect. So think about what could happen. What kind of things could fail and what kind of effect they have. That's what we call a risk analysis. And if you have a clear understanding of the problem, of what is involved, you also know what could go wrong and what kind of effect that has. That's very important to put down, is what is the likelihood of something happening, and what is the potential, the negative effect. So is it, yeah, you have a little pain, or is it potentially that you die, which is then of course very severe. Yeah. Also, of course, this is an ethics course. We need to understand when we should deal with ethics. Is ethics always related to economics to a certain point? The question could arise is, yes, it's maybe not completely checked with respect to ethics, but is it really worth doing it? Or we could also ask the other question: if it has if it could cause an ethical problem for 3% of the potential users, but it's beneficial to 97%, which one is more important, to prevent 3% from getting a negative effect, or for the 97% not getting the positive effects if you don't use it? So this is a very tough thing to think about and to consider in your developments, but it should actually be done. But I'm also in favor of looking at the benefits, not necessarily always looking at the risk of things. So there needs to be a careful weighting between those two things. So particularly when you talk about economics in combination with ethics, I think some of the things I already mentioned is, you need to be also very careful at thinking about in what respect a patient harm or mistreatment could be avoided by using technology, not only looking at what the negative effect on the patient could be if you use it. So it is a tough question. I think one of the things that come up is this driverless car, that there is a potential a decision that the car has to make between a young family, young person, or old person, on if he has to avoid a certain obstacle, and maybe killing some of them. So there is a decision that the system has to make. That is clear. There's a really a moral problem with that, or moral decision making, and an ethical process behind it. On the other hand, please also consider that a driverless car is not doesn't use alcohol, is not drunk, is not affected by being tired or being not completely awake or attentive, is not a drug user, and if you take just these three things, they probably account for 80% of the fatal casualties and deaths that happen in traffic. So these could be avoided. So this is there is a negative part and there is a positive part, and let's be carefully weighting that. And that's also with healthcare. Now, if you don't follow ethical guidelines and you don't ask the question, it eventually comes up and is found out that some of the things that you do have not followed proper strict guidelines and have not followed an ethical, how would I say this, questioning. You may have a big problem, and this problem is negative marketing, is also taking a product off the market. Very big economic issues that follow on that one. So not following ethical guidelines has an economic effect potentially. So consider that as well. So I'm a fan of maybe actually using some form of checklist to make sure that, you know, if, for example, in AI, data that you use has actually been proven to be unbiased, has proven to be not focusing on one sex, or is not focusing on one age group. And so this is almost just like a risk analysis. You need to ask questions, because whatever you use for your analysis, if that has not been checked before, then you basically assume it's okay, and then you're also liable for the results. So I believe that if you follow these things properly, and you have some form of ethical checklist in combination with the risk checklist, you could avoid future issues with the product, and obviously future liabilities, which also has an economic effect. So my proposal, I'm a little bit different than Christian in this one is, but this is cool about this lecture that we are open for discussions, is that I typically start a process of MedTech development by analyzing a clinical need. So what is the problem? Is there really what we call really an unmet clinical need? Is this something that we have not found before, that could be done better, could be improved, could be very beneficial? And then we basically dive into the problem. We try to understand exactly who the stakeholders are. We try to, maybe come up with some baselines for an idea, and also maybe match some economic backgrounds. Who will lose if this idea will actually make it? So if you have a new device that can do a really cool diagnostics for very little money, and giving it to the hands of the general practitioner, the radiologist will lose. The general practitioner will win. You need to know who wins and who loses to know what is the acceptance of certain things. For that one, we use, and we'll talk about this in a second, what we call a value proposition canvas. And the value proposition canvas basically evaluates the current setup, the jobs, what is associated, what kind of gains are associated with that. So what could a customer benefit from if he would have something, and what is the real pain? So like needing 3 hands to do something, which we don't have, is a big pain. So if you actually could make a process that works with 1 hand, you have actually 1 hand free that just does something else. So this is a pain that a stakeholder has, that could be turned into a gain. And then you compare that with what your idea has. So it's basically matching a need with what you have available, what your idea contains. And then what you do is you iterate back and forth. You check on whether you really understand the customer well. you go back and see on whether this pain is really true, because first it's an assumption, right? And then you try to verify this. And that's what a lot of engineers don't do. They don't verify, they just assume and don't check, and then they develop the wrong thing that is not really needed out in the real world. And then there's another canvas that we come up, and this is what we call a business model canvas. This is coming from the same guy, Alexander Osterwald. He developed that. And in this business model canvas, it's kind of like what the name says. It's a business plan on one page. You try to clearly analyze who your customer is, how do you get to the customer, and what is your main value proposition? What is the cool thing about your product idea, about your workflow idea, your service idea, and how do you make sure the customer understands it? How do you get to it and values it? And then there's also ways of finding out what you need to get this done. And what are your business models behind it? So what is the costs associated and the revenues? Now, as engineer, you may say, oh, I have nothing to do with this. No, it's not true. You have something to do with it, because again, if you develop the wrong things and you ask the wrong questions, it is the most frustrating thing if you finish something up that nobody needs. So I believe that all of us need to be a little bit more economic and asking questions with respect to future use, rather than to actually follow a plan, or at least make sure that others have done this job. So, but that requires that you know about it. So again, what's the customer, what's the need, and it's all done on one page. And the nice thing about it is to use sticky notes, and whenever you find something out that is wrong or correct, you can replace it. It just update your business plan on a daily, weekly basis whenever you learn something new, which is normally not done if you have a normal business plan. Okay, and based on that, you develop prototypes, and we call them MVPs, minimal viable prototypes, and then reiterate and check again and do this process continuously. That makes sure that you avoid developing the wrong things and invest too much time, too much money in developing something that nobody needs, nobody wants, and where there's other things around that probably do it better, cheaper, faster, whatever. So the future after that would be that you really, once you have done that, once you have figured that out, that it is a good thing that you have built some minimal viable products, that you actually go in the future and implement it. And then I believe this, as part of this iteration process, it is very important to then raise these ethical design consideration questions. Why am I saying this so late? Because if you ever ask these questions too early, you may be sidetracked and focus only on ethics rather than on coming up with the idea. I think an idea can be fine-tuned and can be compensated once you know about the risks, once you know about the ethics risks, but not too early. So that's at least my opinion. And again, there may be other people who have a different opinion on this. And what I'm trying to communicate in this entire process is that you, as the designer, biomedical engineer, somebody who wants to come up with innovation, you need to find a painkiller for a burning problem. A burning problem, and I believe it starts with the burning problem. You need to know what kind of burning problem is out there that I need to find a solution for. Because what a lot of researchers do, I'm not just trying to discredit research at all, but they have a painkiller, but they have unfortunately not found a burning problem that painkiller solves. So I think if you really want to do something that is useful and innovative for healthcare, you start with the problem and not with the solution. Okay, I think most of the stuff that is mentioned over here, I've already mentioned. That's why I don't want to necessarily go over that again. And it's actually something that Christian is probably much better at than me anyway. But maybe as a last sentence, I believe that ethical design considerations are really important to make sure that a product has a good and long life and will actually solve an issue and solve a problem. But I'm not sure that we have to start with ethics in all the way at the beginning, before we really understand the problem, before we really understand the issues, and before we know what our product idea solves or what kind of implications it could have. So I believe that ethical questions are kind of like a checklist, just like the risk analysis, and we need to make sure that we follow that. But setting this up front too early is also restricting our innovation mind. I do not want to go into the depth on the value proposition business model canvas. This would take significantly more time, but what I've given to you is a very a nice explanation, very using a lot of picture evaluation on what a value proposition canvas does and what a business model canvas does. I've given you here the download links. They're all from Alexander Osterwalder, the inventor of this, and they give you, I think, a great tool set for future checks. So in my lab, that's the first thing we do is we try to map the identified problems, try to map the stakeholders, try to map their needs, their problems, their pains and gains that we could achieve. And then we develop something, and then we maybe try to put it into a business model canvas. Now, while it says business model canvas, it is something certainly that you use for a business model. It is something that makes you understand the value chain of an innovation. If you don't understand the value chain, you don't think there is a value chain, then remember the sentence I said: innovation equals invention times commercialization, or replace commercialization with, is there a need for it? So if you don't check the need, if you don't understand it, then you may develop something, you may spend a lot of time for something that nobody ever needs. So I give you an example. I thought that was easier to do, and use the value proposition canvas in combination with an idea. I, at some point in time, 15 years ago, developed a conscious media injector for an MRI. So basically inject into the venous system a conscious media. You see that on the left. You think you see my, no, you don't see the cursor, but on the left side, this is a typical one that was used, and the company that asked me to do a development said, please do one that's exactly looking the same, does the same thing, but doesn't infringe any patents. Issues with this injector where it was very heavy. It was not fully compliant to an MRI installation. It was made out of metal, and you couldn't really go all the way into the scanner. It was battery backup, which means if you have a battery, it can also be empty, and it's always empty when you really need it. I think that's typical. And it's a 20,000 euro device with quite a bit of follow-up cost per patient. What we never looked at, because they wanted us to do something similar, what we never looked at is it actually possible to be really disruptive? And disruptive in that sense means, can we do something that is a factor 10, 100, 1,000 cheaper than what is currently out there with the same functionality? So we never looked at, is it all necessary what we are doing? Can we reduce complexity, cost, and handling, and make something dramatically easier to use with less error margin and with dramatically reduced cost? And we actually did that now. So first of all, we used this value proposition canvas and try to understand by looking at, so here it says MR conscious media injector. We looked at the private radiology. That's our stakeholder. That's our customer right now. And we looked at a particular feature. Is cheap and easy to use really something that is important to them? And so first of all, you need to start with understanding, what is the customer's job? What does need to get done? Why does he need to have this injector? So in our case, find pathology using MRI imaging, have a low error margin, high standard follow-up procedures, because you can also inject the conscious media by hand, but then it's not standard. Everybody does it differently. What is a pain? A pain is conscious media is quite expensive, so you need to be careful. You have a high setup time because you need to program this device. You need to have put the lines on there. So it's quite a time. We've been about 10 minutes per patient on it. It's relatively difficult to use because you have a computer system there. You can do things wrong. What kind of gain could be provided if you would do something that is cheap and easy to use? Well, they could recover the cost easy. They would have maybe with an easy setup forensic quality assurance, so they can actually say at what time was what injected and was there any faults. And of course, if we would provide something to them that is very easy to use and no error, you would, because the radiographer is using it, not the private radiologist, even though I've put it for the private radiologist, they would be very, very interested to use that. And so we were looking at what could our device do if you would build one. So what kind of, let me just go back, what kind of gain creator would it have? So it would be 100% MR compatible. If you, for example, use a complete plastic one, we would limit to one flow rate, and that would provide very low investment and operational cost, etc., etc. Now, when you have done that, you can always pick the most important part of each of one of these segments and create what we call an elevator pitch. So if you take the most important one from the products and services side, in this case, one flow rate MRI, you use the customer segment, which we defined as private radiologist, etc., etc., and you just plug this into this scheme. You can come up with a description of what your idea can provide to a customer, and you can very quickly check on whether that's something a customer will be interested in. So in this case, you could read the sentence now: our one-flow MRI contrast media injector helps private radiologists and radiographers who want to use and employ high standards in MRI imaging follow-up procedures by simplifying an application that is difficult and by reducing handling errors and procedure cost. Unlike, and now you put down what's been done before. Now this is almost like that's why we call it elevator pitch. It's something you can communicate to a person within 10, 20 seconds. What are you doing? What are we proposing? And is this something you're interested in? Rather than stumbling along in 10-minute conversations and trying to explain what you do. This is followed up by a business model canvas. You now try to analyze more. Is there something that is actually, this idea, can it actually be turned into a viable product? Viable means is somebody interested in it? And they made this, Alexander Ostrova came up with this approach of actually using these 9 segments, and it all circles around these value propositions in the middle. So what is so cool about your device? What is the kind of value that you propose to a customer? And then on everything on the right side has to do with the customer. Who is the customer? How do you get to the customer? Everything on the left side is associated with what do you need to get it done? What kind of partners do you need? What kind of activities do you need? What resources do you need? And it also has costs and revenue streams, which are not so important for us at the moment. It's just, do we understand the customer and the needs? And do we believe that the value propositions that we provide are really valuable? So in typical for MedTech products, a life science product, you would start with the value proposition, would take your time with the customer segments, and then understand what kind of key activities are needed to get it done. And again, check every time you learn something new, put it down. Every time you learn that some assumption you had before is wrong, you take a bit off and update it. Almost business plan, you can explain your model, your idea very well just on this one page. This is just a little different setup. So there's some rules below. You should not do too much on a yellow stick on a sticky note. Just one rule, maybe color coded. Don't do a lot of blah blah blah. Be very precise. And if you do that, you have a really cool way of always understanding what are you really trying to do, who you're trying to address, and what kind of questions you have to ask. Now, this is also seen in the context of design thinking. You may have heard about this before. Design thinking is something that checks a development process. Also starting with, in a way, it starts with a problem. It starts with an empathy. You need to put empathy forward towards a problem or a user. You need to understand how he, she works and what kind of problem they have. Once you have understood that, you define the problem and then you start to ideate around it, create a prototype, test the prototype. And this is an iterative process. You go back and forth all the time. And this is in contrast to some of the development processes where you have a plan, then you do something, and then you check. That takes a long time. You invest lots of times in the development process before you find out that something is wrong. Here, you just try to iterate very fast, and it's more important to be faster than to be too accurate, because you always find out what things are not working as well. So build a lot of minimal viable products, and I'll show you what that is. And check with these minimal viable products and whether the future big idea is really valid. And then there's an empathy map. So you need to understand the customer and ask questions, for example. But very often when you ask a question, or for example, you ask the question, it's like, what do you want to have? You will get something that is not true, or that is maybe not sincere, or that is maybe not really matching future potential and opportunities. And maybe the customer doesn't even know what they want. Maybe you have to just detect it yourself. So you need to not only spend time asking, but also spend time analyzing the workflows and process. You need to observe. And if you do that, you will find out that there's a difference between what a customer says and what he thinks, feels, and does. And that is what we show here on this empathy map. Is a very important starting point for coming up with that real problem that you try to identify. Another strategy, and I know I'm going a little fast, and I'm throwing this stuff at you, but this is one of the innovation strategies that I use, and I think you should just have heard about it. That's why I have one slide on this. Is what we call a blue ocean strategy. And the blue ocean is the opposite to a red ocean. Red ocean is full with blood, right? There's a lot of competitors around. With the blue ocean, you try to actually find something that nobody else has, but that is important to the customer. So you need to analyze the need, the importance of a need, and you just focus on that need and not focusing on all the other stuff that is maybe not needed. Remember that injector again that I said before? All the old other injectors, they have 10 flow rates of which you don't need. You need none. You only need one flow rate. So why do you have all these options of these flow rates? So what we did is, by concentrating just on this one flow rate, we could reduce the cost already by 90%. We could get rid of motors, we could get rid of computer systems, but that's the only thing the customer needs. So why have all this stuff? And so this is what blue ocean means. You concentrate on the most important thing for the customer. Well, which is the most important? You need to find out which is the most important. Then you focus only on this one. And by doing this, you can create something that is maybe even better, provides exactly the feature the customer wants. You can do it dramatically cheaper and probably more effective than others. So this is what's meant by blue ocean strategy, finding disruptive concepts and products. This is the value innovation part, so this is the second part, so I'll just go over this quickly. Prototyping. So now we go into these MVPs again to have to show customers and to have this iteration process. It's very good to have prototypes, and you need to build prototypes. And the question is, what is a prototype? So here is a definition of prototyping: process of building quick, cheap, and rough study models. Study models, because you want to show a feature, a value proposition, and you want to check on whether the customer really appreciates it or not. So there's an example here. If you want to build a car, you could actually decide to build the car, but it takes a long time, would cost a lot of money. Or you look at the value proposition of a car, which is bringing one person or more from a place A to a place B faster than walking, for example. That could be the value proposition, right? Now you can prove this with a car. You can also prove that with a skateboard or a roller or a bicycle or a motorcycle. These are the minimal viable products that go faster, but prove the point of getting faster from A to B. So you can maintain the bottom part here, building these products, see if the customer likes this, appreciates the value proposition before you actually end up with a car. If the ones on top would have waited 3 or 4 years, they could have developed the wrong thing, and maybe the customer wasn't really interested in this value proposition. So as a summary on this one, sell the problem you try to solve, not the product. Understand the problem first, and don't define or develop anything without having understood the problem properly. So here's some of the innovation principles. I just put them down, for example, of Google. I don't think we have to go in depth on this one. I think I mentioned quite of those already. Focus on the user. That's that iteration process. Never fail to fail. This is also the idea with these minimal viable products. When it doesn't work, then you drop it and do something else. And because you understood the problem, you may actually find a different path to success. Don't focus on one thing, and if it's not good, fail, but fail quickly and fail early. Several things on new technologies. I'll just throw them in. McKinsey, that's a very recent publication about what will happen, what kind of technologies will come up in healthcare. They identified 9 emerging technologies. I don't know, blockchain is part of it too. So, and what they will be used for. They will be used to do a lot of evaluations, transaction improvements, economic systems improvements, delivery system. So there's a lot of innovation potential in there. Just they look also at what has these technologies, what they have made. They have reduced cost of sequencing, for example, exponentially down, which means everybody can have that. Now, it's not a technology that is not affordable. Everybody can use it. So if everybody can have it, why not use the information that comes with it and do something better with it? There's a lot of investment being made. Healthcare is something that certainly is important to every one of us. Every one of us will deal with it at some point in time, and that's why there's a lot of money being put in, and there's a lot of interest also in the future on this one. A lot of different design rules you should look at. So also, I don't want to get into this. I think this is something you can, excuse me, you can check later on. Of course, there is something that should be added, which is the ethics part. That's actually one of the goals of this class and lecture, is that we teach you some of the ethical thinking, but also teach you that to actually apply that, we need to come up with new innovations. So the combination of those two things is very important. There's a lot of things that everything that has to do with healthcare is there's a massive amount of people and organizations interested in it. There's a lot of stakeholders in there. And every time you do one thing that benefits one stakeholder, it probably hurts somebody else. So it is very difficult, and also society, maybe something that benefits the young people but hurts the old one, and vice versa. So there's a lot of issues around it. And so I believe that there's tons of opportunities in there, and there's a lot of disruption that will go on. And so this is a couple of the people I follow that I believe are very interesting, that respect, and if you're interested, follow up on this as well. So now we start with the canvases. So we had already business model canvas, we had value proposition canvas, we have an ethics canvas. This is something, it pretty much looks like the business model canvas, also has these 9 points with the center of what can we do. I don't want to go in depth on this one. This is Christian's job to do, but this is canvas number 3. And then we have 2 more canvases that come up. One is the MTP canvas, and the third is the exponential attributes canvas, which will come in a second. So I have a homework assignment for you, and that has to do with COVID-19. There's a lot of uncertainties that will have a significant impact or possible impact on social, technology, economic, environment, and politics. What I want you to do is I want you to read something, and I'll give you the download link for that one later on. And you basically come up with a statement. There's four different options that they believe can happen with these changes in COVID-19. Get yourself, read yourself into it, and maybe, not maybe, try to come up with a statement from you and what you believe will happen and what you believe should happen. So particularly also with respect to the healthcare system. And these are the 4 things. So we'll have a passing storm, everything will go away. Lone wolves, good company, sunrise in the east. So look at the definitions of those ones, of those scenarios. Tell me what you believe will happen and what you believe should happen. So this is your homework assignment 2. I put these in a different sheet anyway, so you can download them. So look at page 15 forward. And what I would like you to do too is to look at 2 different places, to look at from your statement on Europe and in India, just to have 2 different perspectives. That's empathy again. Put yourself into the position of the Indian setup and seeing whether that's different. I'd be very interested in seeing what the outcomes are of this one. So things in terms think in terms of access to healthcare, focus healthcare, etc. All the things that I mentioned down here. All right. I got to the MTP canvas. So this is the 4th out of the 5 canvases. And I want to do a little exercise with you. MTP stands for Massively Transformative Purpose. And I believe every one of us should have a massive transformative purpose, something that we really are extremely excited about, interested in, that we believe our life should be geared towards. And this is obviously something you can change. This is not something that is carved in stone, but you should have a little bit of a thinking process behind it. And so I want to go through through that MTP canvas with you, so you develop your own massive transformative purpose. And the whole thing is set up in like the personal part. What are your superpowers, your personal superpowers? What is the general challenge that you want to deal with, that you want to employ these superpowers in? And then try to see how you actually get them converted into an impact in the world. So this is that's what then creates that that MTP. So let's start at the bottom. You basically start from the bottom left, and kind of like zigzag your way up. So first thing you would do, look at your values. So what is important to you in this case? Love, honesty, justice. What are you longing to? What is something that you really think is important? What you believe is something that should happen? Like treat others as I would like to be treated. My superpower is that I communicate effectively. My kingdom is a society of and the inhabitants of this society are people without resources, so the poor ones. I really want to have as a challenge, or see that we create equal opportunities. And I want to go through this. I want to leave a footprint by actually educating better people. By creating better people through education. And I want to do this by creating education materials and build platforms to democratize knowledge to everyone. So if you use this, the MTP could be, and in this case is, democratizing education. This is what you're driving for. This is your personal drive and motivation in life, and all the things you do are kind of like governed by this. I have actually done this for myself. So this is my MTP, and I've looked, so you can actually follow this now. My MTP is healthcare, democratize, enable. So I want to give people tools and ways and educate them and train them to come up with devices and tools that make healthcare more equal. So this is what I'm investing in. That's what I'm thinking in terms of innovation in, and that's what I'm really extremely motivated and focused about. So what I would like you to do is actually work on your own personal MTP and just create. This is an exercise for you. It's not for me or for Christian, it's for you. And I think it's a great exercise to give yourself an initial purpose. And of course, you know, this is your personal one, so we would definitely keep it confidential if you don't want to talk about it. There's another way of looking at that, also with respect to a formulating innovation. So this MTP is like the governing, so healthcare, democratize, enabler in my case. And then if you really think in terms of exponential, not only technologies, but ways of actually putting that into the society, you can have what they call internal attributes, those are ideas, or the external attributes that are abbreviated with scale. So just as a quick one, experimentation, an internal one, if you allow within your company your employees to experiment around, to check out things very much, you will get great insights. Not everybody can afford doing this, but this is a feature, an attribute that a company or a venture could have to create great ideas in the future. This requires autonomy, another internal one. If you don't allow people to do this, they will not be willing and capable of doing this. So some of the internal ones. External ones is, if you have a community and crowd that really likes your product, likes your ideas, and maybe even talk about it constantly, they will be your best customers and your best marketeers. They will tell everybody else of how cool it is. And if you involve then maybe some form of engagement platform, software platform where people can exchange ideas, then this is a multiplication effect that is enormous. So what I would like you to do, this is that exo canvas, don't look at it right now. This is just how you can place things from an idea perspective and use these exponential attributes to actually make a really, really, really good future-proof project. What I would like you to do is to actually uh, get into this openexo.com. This is the organization that promotes these things, and do the EXO Foundation certification. It's a free program, and this free program just gives you some insights in it. This is not marketing or anything. This is just giving you some insights. You can also download things, and it's a homework assignment. And please forget this, what I put down here, but please remember penalties, blah, blah, blah. This is something which we did for last year's class, so ignore it. So homework assignment would be get the foundation certificate. It's a 1 hour investment, and I think it will also dramatically, or it will give you extremely good insights in the future. Okay, I'm done with this one. Thank you very much for listening. And again, I'll remind you that on May 22nd, I'm available for a talk, 18:05, Zoom conference is given. Thank you very much, and back to Christian. So.